So let's just arbitrarily hop in here and pick R and T. Okay, so let's operate off R, capital R, T, and capital T. And I've said I'll start with a sign. So let's say you're doing the sine of R. You definitely know you have a sine of T over here. Okay, that's an absolute for certain. And then you know that the factor it's going to be multiplied by is going to have a sign at the bottom. And that's going to have to be the sign. No, it doesn't, silly me. Okay, so if you do it this way, because I've got my sign over here, if you're doing it this way, this is going to have a T at the bottom, and this is going to have a NOR on top. Okay, so your OR goes this way. So I need to come at it a slightly different way, because that wasn't very successful. I'm making myself look a bit silly here. Okay, so we go at that again. Where again, our goal is to approach it purely literally. So let's go with D, E, D, and E. The bottom being the angles and the top being this. So let's say we're going to start, say, with the sine of angle D. Sine of angle E will be proportional to it. And that will tell me I want an E at the bottom and a D at the top. Okay, so you see those D's stretching across at each other, across the equals, and the E's stretching up and down. Okay, and but you could also say, and this is just purely how you look at it, if you're going to say that D is proportional, sine of D is proportional to little d, then what you're saying, well, I'm finished with my D's now, I have to come on in here with my E's. And you say, well, sine is proportional to sine. Okay, and length divides length. Okay, so now you're going to see, hopefully at this stage, and you've had a lot of lecturing now, but hopefully you pause and you practice. So I'll give you an opportunity to do that. Okay, I'm going to give you two sides. Sides B and N, and two angles. Angle B, obviously, and capital N. So this is what I want you to do. I want you to write down directly the formula for this sine of B. And you can pause now. Okay, I'm back to you. So if you're writing down the formula for the sine of B, you might come across here and say, well, this is definitely the sine of N. Having done that, you can say the B here definitely wants a little b on top, and the N here definitely wants a little n underneath. Okay, I'll give you another task. We'll pick the letters A and T. So I want you to make the side T equal to something, and you can pause now and get to work on that. Okay, I'm back to you. So you have gone T is definitely proportional. Now you can do this in various ways, but you can say T has to be proportional to the other side A, or you can say T has got to be proportional to the sine of T. It doesn't really matter because they're both directly proportional. Actually, more about that in a second, and then we'll start talking further. So so I've done that now, and now I need a sine over a sine. Well, down here will have to be the sine of A, so that the little a and the sine A are directly proportional to each other because of the fraction bar, and the T has to be directly proportional to the sine of T, so that goes like that. Okay, so this is going to be your introductory lecture. That's your more or less done, but I've just thought of another idea that I want to throw at you, and it's returning all the way back to this formula. So if I tell me how does that relate to the diameter of the circumcircle, I want you to come in there and say it's this. Now, how would you avoid the error of saying that equals D, or 2R, and what you would do is, well, these are the distances at the bottom. So if that's true, then this is 1 over twice the radius of the circumcircle. Circumcircle is the circle that goes through the 3 points in the that goes through 3 points of any triangle. That gives us its circle, and that has a center, and that center is the center of the circle. And you get that center, of course, by bisecting each one of these perpendicularly and find where they bisect each other. Okay, and that's one of the constructions that's on your course. The third one is optional. It is concurrent, meaning the 3 lines go to cross at one place. Quite a unique idea. Typically 3 lines don't cross at one place, so that's quite unique. And then, so back to the thing I want to tell you is that if I ask you what's the sign of A proportional to, you'll tell me A as a valid answer. Someone else would say, hang on a second, it's proportional to sine of B. That's true, and because what we have is we have a multi-proportional problem here. Okay, and the two of the proportionals are direct, in that A is proportional to sine of A, and A is proportional to B, and A is inversely proportional to the sine of B. In other words, if I cross multiply there, you're going to get A sine B is equal to B sine A. Where obviously I'm talking in one particular manner, but I should say little a sine big B is equal to little b sine big A. Okay, because mathematician isn't... Euler, one of the greatest mathematicians of all time, did most of his best work when he was blind, so we shouldn't just consider it for everybody. Okay, I mean, maths is for multi-senses, but the visual aid certainly helps us pure mortals. Euler just didn't need it. Okay, that's Euler, like as in E-U-L-E-R. Okay, so what am I talking about here? Basically, A is inversely proportional to sine of B, and B is inversely proportional to sine of A, because whenever a product seems constant, and that would be if you lock in B and angle A. Now, could you do that? Like, could you say to me, hey, what I'm going to do is I'm not going to make that change in any way, and that's that. And having done that, interestingly enough, there is, no, that's angle A up there. So you'd come out here and you'd say, I'm going to pick a point. You can see I have a point A up here that's dynamic, it can move, and I have some point B here, which is also dynamic, it can move. B here, and there's going to be a side length B. So what I'm saying is, if I force these things, so there's another point, no, that point I can't go there, that has to go here like this. Okay, provided I'm putting another point in here. C goes in here. So what am I talking about? Length A is here. The bigger I make the angle, the bigger I make the length. And if the constant of proportionality, but it's not linear, okay, that's the problem. Like, even A is not, it's only directly proportional to sine B as long as this is constant. And of course you can't make this constant. I'm struggling here to say, how can I make B constant? And forget about it, I'm probably trying to create a situation that's impossible. Whether I am or not doesn't really matter. It's a good idea, and I'm pushing it to the limits of how much well you can understand this. But if you could consider B sine A in some way to be locked down, or at least to be literally locked down in its own space, even if these are changing, we can then say that because A sine B are going together like this, then A is proportional to 1 over sine B. And so this is another thing to focus in on. Whenever you're writing down a formula in any form, A and the sign of the opposite letter are either inversely proportional, or else they're or saying that is the exact same thing, because that is another way of saying inverse proportionality. Okay, so it's another thing that's quite helpful. So if I tell you, if I go P equals sine of t, you can fill in the rest. That's enough. You know, and if I tell you nothing else to the left, we'll always make the left the subject of the formula. If I tell you the sine, where are all my letters that I liked so much? If I tell you the sine of A equals B at the bottom, you can fill in the rest. What I can never do is say the sign of Q, but I can give you a top. Yeah, I can give you a top, but I can't give you a Q because then I haven't told you what the other letter is, obviously. And that would be true, but it's just going, well, you have to make up a letter. You would have to make up a letter in that case. But then sign of Q, but then go back. Let me go back to not giving you something completely stupid. So if I told you the sign of Q is equal to T, you'd be able to fill in the rest. So I'm going to ask you to pause and fill in the 3 of these. Okay, you're back to me. So when I see a P here, I know I need a sign of big P here. And when I see a sign of T here, and when I see a letter here, I know I need a letter here, and that letter. Oh, hold on. No, that's good. No, that's not good. Stupid me. God darn it anyway. No, sign of P would be down here. That would be okay. And sign of P would come up. Sign of P, P over sign P is equal to T over sign T. Yeah, there we go. Sign of A needs an A over here, and a sign on the left needs a sign on the right, and the sign and the B at the bottom needs a sign of a B. See, so we've loads of ways to keep us on the straight and narrow. A sign of Q, yuck, Q at the bottom. That's a mistake. You can't have a T on the top. Okay, because this is going to need a letter on the top, which is going to be Q. So the other letter has to be on the bottom. Sorry about that. And then once you have that other letter, then it has to be the sign of T. And I'll just put it there. Okay. So it's going to be a long introductory, very, very kind of abstract in that we're only using letters. But we'll get into problem solving in the next video. Thank you.